Hello, sleepy genius. Another day has passed, and now it's time to let your thoughts drift beyond the familiar. Close your eyes and feel the weight of Earth beneath you begin to soften. Tonight, we're leaving home behind, traveling through the solar system one sleeping spot at a time, where gravity shifts and skies transform in ways no human has ever witnessed. From frozen methane lakes, where rain falls upward, to skies filled with diamonds, the planets in our solar system are stranger than any dream. What would it really be like to spend just one night on each world? Not to conquer or explore, but simply to rest under alien skies and witness what no human eyes have seen. Before our journey begins, if these curious facts help you rest and leave a weary day behind, a simple like or subscribe helps others drift here too, one soul at a time. Please share your thoughts below. Now, let's begin. On Mercury, your bedroom would need to face away from the sun, tucked into the permanent twilight zone where temperatures hover around a almost comfortable range. Picture yourself in a shelter built into the shadow of a crater rim, where one side of the planet bakes at 430 degrees Celsius while the other freezes at -180. Your night would last 58 Earth days and 15 hours, which is how long Mercury takes to complete one rotation. NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, revealed that some polar craters contain water ice, protected in permanent shadow. The Calaris Basin, a crater 1,550 kilometers wide, was formed by an impact so powerful it created hills on the opposite side of the planet. To think that you could watch the sun appear to rise, set, and rise again in the same Mercurian day due to the planet's elliptical orbit, a phenomenon called the Mercury effect that occurs nowhere else in our solar system. Venus would require a floating habitat suspended 50 kilometers above the surface, where atmospheric pressure matches Earth's and temperatures reach a mild 20 degrees Celsius. Imagine drifting through clouds of sulfuric acid while below you, the surface temperature reaches 465 degrees Celsius, hot enough to melt lead. Soviet Venera landers in the 1970s and 1980s survived on the surface for only minutes before being crushed and melted, with Venera 13 lasting a record 127 minutes in 1982. The atmosphere is so thick that it would feel like being 900 meters underwater, with atmospheric pressure 92 times greater than Earth's. A day on Venus lasts 243 Earth days, making it longer than a Venusian year of 225 Earth days. And the planet rotates backward compared to most planets, meaning the sun rises in the west. Russian scientists discovered that the upper atmosphere contains dormant bacteria-like particles, though whether they represent life remains unproven. This reminds us that the most hostile places can hide pockets of possibility, floating islands of calm in a world of chaos. On Mars, you'd set up camp in Valles Marineris, a canyon system that stretches for 1,000 kilometers long and plunges 7 kilometers deep, dwarfing Earth's Grand Canyon. Picture laying your sleeping bag on rust-red sand that contains perchlorates, watching Phobos race across the sky 3 times per night while Deimos barely moves. The Martian day, called a sol, lasts 24 hours and 37 minutes, so your circadian rhythm would adjust slowly over months. NASA's Curiosity rover, exploring since 2012, discovered organic molecules in 3.5 billion-year-old mudstone at Gale Crater, suggesting ancient lakes once filled this landscape. Nighttime temperatures plummet to -73 degrees Celsius, and the atmospheric pressure is less than 1% of Earth's, so your habitat would need to maintain pressure while protecting you from radiation that's 50 times stronger than on Earth. In 2019, the InSight lander detected Marsquakes, revealing that Mars has a molten core and remains geologically active. To close your eyes knowing that water ice lies beneath your feet, that ancient riverbeds once flowed here, and that you might be sleeping above the fossil record of another world's attempt at life. Jupiter has no surface to sleep on, only layers of hydrogen and helium compressing into liquid metal as you descend into pressures millions of times Earth's atmosphere. Imagine a floating research station hovering where atmospheric pressure matches Earth's, surrounded by ammonia ice clouds colored in bands of red, brown, white, and tan. The Great Red Spot, a storm system larger than Earth that has raged for at least 350 years, was first observed by Giovanni Cassini in 1665, with wind speeds reaching 432 kilometers per hour at its edges. NASA's Juno spacecraft, orbiting since 2016, discovered that Jupiter's storms penetrate 3,000 kilometers deep and that the planet's magnetic field is 10 times stronger than Earth's, the most powerful in the solar system. A day on Jupiter lasts only 9 hours and 55 minutes, making it the fastest rotating planet despite being the largest. You'd witness lightning strikes 1,000 times more powerful than Earth's, flashing in the clouds like strobes, while 79 confirmed moons orbit in the darkness beyond. In a sense, sleeping on Jupiter means floating inside a cosmic engine, a failed star that radiates more heat than it receives from the sun, forever churning in its own ancient momentum. Your bedroom on Saturn would float at the same atmospheric level as Jupiter's, surrounded by hazy gold and butterscotch clouds made of ammonia crystals and hydrocarbon smog. Picture watching the rings from below, a geometric impossibility made real. Billions of ice particles ranging from dust grains to house-staged chunks reflecting sunlight in a band 280,000 kilometers wide but only 10 meters thick. Christian Huygens first observed the rings in 1655, though Galileo saw them in 1610 without understanding what they were, describing them as ears on the planet. NASA's Cassini mission, which studied Saturn from 2004 to 2017, discovered that the rings are actively forming moons and that ring rain constantly falls onto the planet. Particles spiraling down from the rings at a rate that suggests they'll disappear in 100 million years. A day lasts 10 hours and 33 minutes, and wind speeds reach 1,800 kilometers per hour at the equator, 4 times faster than Jupiter's fastest winds. The moon Enceladus shoots geysers of water 500 kilometers into space from an underground ocean, and Titan has lakes of liquid methane where it rains gasoline. This reminds us that beauty and violence can occupy the same space, that the most elegant structures in the solar system are also temporary, melting into the planet they encircle. Uranus would force you to sleep on your side, metaphorically, since the planet rotates at a 98-degree tilt, essentially rolling through space like a barrel. Imagine a habitat floating in cyan blue clouds made of methane ice, where the sun would appear as a bright star and a day lasts 17 hours and 14 minutes. William Herschel discovered Uranus in 1781, the first planet found with a telescope, initially mistaking it for a comet. NASA's Voyager 2 remains the only spacecraft to visit, flying by in 1986 and discovering 10 new moons and a faint ring system. The extreme axial tilt means each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness during its 84-year orbit around the Sun. Temperatures in the upper atmosphere reach -224 degrees Celsius, making Uranus the coldest planet, despite Neptune being farther from the Sun. Scientists believe a massive collision with an Earth-sized object billions of years ago, knocked Uranus onto its side and created its 13 known rings and 27 moons. To think that this blue world spins through space like a wheel, its seasons measured in human lifetimes, its rings invisible except from certain angles. Neptune would offer the wildest night in the solar system, with winds screaming at 2,100 kilometers per hour, the fastest in the solar system, ripping through an atmosphere of hydrogen, helium, and methane. Picture your floating station being buffeted by storms the size of Earth, while the planet's distinctive blue color, caused by methane absorption of red light, deepens around you. Johann Gohl discovered Neptune in 1846 at Berlin Observatory, the first planet located through mathematical prediction rather than observation, with Urbain Le Verrier and John Couch Adams calculating its position based on irregularities in Uranus's orbit. Voyager 2's flyby in 1989 revealed the Great Dark Spot, an Earth-sized storm system that had vanished by the time Hubble observed Neptune in 1994, suggesting Neptune's weather changes faster than any other planet. A day lasts 16 hours and 6 minutes, and the planet completes one orbit every 165 Earth years, meaning Neptune has completed only one full orbit since its discovery. The moon Triton orbits backward and shoots nitrogen geysers 8 kilometers high, and Neptune radiates 2.6 times more energy than it receives from the Sun. In a sense, Neptune represents chaos refined into beauty, a sapphire spinning in the darkness where physics pushes atmospheric behavior to its absolute limit. Pluto, though no longer classified as a planet since 2006, would offer the quietest night in the solar system, a dwarf planet where your habitat would rest on nitrogen ice plains. Imagine standing in Sputnik Planitia, a frozen plain 1,000 kilometers wide with no impact craters, suggesting the surface is less than 10 million years old and somehow renewing itself. Clyde Tombaugh discovered Pluto in 1930 at Lowell Observatory in Arizona, and it remained unvisited until NASA's New Horizons probe flew past in 2015 after a 9-year journey. The mission revealed heart-shaped Tombaugh Regio, mountains of water ice 3 kilometers high, and a blue atmospheric haze made of nitrogen and methane. A day on Pluto lasts 6.4 Earth days, and a year takes 248 Earth years, with temperatures at minus 233 degrees Celsius. The moon Charon is so large relative to Pluto that they orbit a point in space between them, making them a binary system. To close your eyes this far from the Sun, where sunlight is 1,600 times dimmer than on Earth, where the sky would appear perpetually dark even at noon, and where the silence would be absolute in the absence of any atmosphere thick enough to carry sound. Haumea, discovered in 2004, spins faster than any other known object its size in the solar system, completing one rotation every 3.9 hours and causing it to elongate into an ellipsoid shape 2,322 kilometers long. Imagine trying to sleep while experiencing a day that lasts less than 4 hours, where centrifugal force has stretched the dwarf planet into a football shape with dimensions of 2,322 by 1,704 by 1,026 kilometers. A team led by Mike Brown at Caltech discovered Haumea and its 2 moons, Hayaka and Namaka, named after Hawaiian goddesses. In 2017, astronomers observed Haumea pass in front of a star and discovered it has a ring system, making it the first known Kuiper belt object with rings, located 2,287 kilometers from its center. The surface is covered in crystalline water ice, unusually bright and reflective, suggesting a massive collision billions ago stripped away the outer layer and created the moons. your habitat would need to anchor against the extreme rotation, where surface gravity varies dramatically between the poles and the elongated equator. To rest on a world spinning itself into an oval, where physics and collision history combined to create something that defies our expectations of what a planet-sized object should look like. Eris, discovered in 2005 by the same team that found Haumea, is slightly smaller than Pluto but 27% more massive, making it the most massive known dwarf planet in the solar system. Picture your sleeping quarters on a surface covered in methane ice, so reflective it bounces back 96% of incoming light, making Eris brighter than fresh snow. Observations from the Atacama Large Millimeter Array in Chile revealed in 2015 that Eris's surface temperature averages -231 degrees Celsius, cold enough that its thin atmosphere of nitrogen and methane freezes and falls as snow. The dwarf planet takes 557 Earth years to complete one orbit, currently near its most distant point from the Sun at 96 astronomical units, about 3 times Pluto's current distance. Eris has one known moon, Dysnomia, discovered in 2005, which orbits every 15.8 days and allowed scientists to calculate Eris's mass precisely. A day on Eris lasts approximately 25.9 hours, giving you a sleep cycle remarkably similar to Earth's. The discovery of Eris directly triggered the 2006 redefinition of what constitutes a planet, leading to Pluto's reclassification and the creation of the dwarf planet category. In a sense, Eris represents the object that rewrote our solar system's family tree, a frozen world so significant it changed textbooks across an entire planet. Sedna, discovered in 2003 by Brown, Trujillo, and Rabinowitz, follows one of the most extreme orbits in the solar system, taking 11,400 years to circle the Sun once with a closest approach of 76 astronomical units and a farthest point of 937 astronomical units. Imagine establishing a habitat on this reddish world, one of the reddest objects in the solar system after Mars, colored by tholins created when methane ice is irradiated by cosmic rays over billions of years. Your night on Sedna would occur during a day estimated to last about 10 hours based on brightness variations observed from Earth at its current distance of 84 astronomical units. The Sun appears as merely a bright star, providing 1,900 times less light than Earth receives. Scientists believe Sedna's unusual orbit suggests it was pulled by the gravity of a passing star billions of years ago, or possibly by an as yet undiscovered massive planet in the outer solar system. The dwarf planet measures approximately 995 kilometers in diameter and has no known moons, making it a solitary traveler through the outer darkness. To close your eyes on Sedna means resting on a world that will continue moving outward for another 5,700 years before beginning its slow return journey, a timescale that makes human civilization seem like a brief flicker. Jupiter's moon Europa would offer a more practical sleeping location than the gas giant itself, where you'd rest on an ice shell 15 to 25 kilometers thick, covering a liquid ocean 100 kilometers deep. Picture your base camp near Puil Crater, where young ice appears bright white against older, radiation-darkened surroundings, listening through instruments to the creaking and cracking of tidal forces flexing the ice. NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003, discovered that Europa generates a magnetic field, suggesting a conductive liquid ocean beneath the ice interacting with Jupiter's magnetic field. In 2013, Hubble Space Telescope observations detected water vapor plumes erupting 200 kilometers above Europa's surface, similar to those on Saturn's Enceladus. A day on Europa lasts 5 Earth days, tidally locked to always show the same face to Jupiter, which would dominate the sky at 24 times the apparent size of our moon. Your sleeping module would need to withstand radiation doses 540 rem per day, about 1,800 times Earth's surface level, to close your eyes knowing that beneath you lies more liquid water than exists in all of Earth's oceans, a dark sea that might host hydrothermal vents and the chemistry of life in permanent darkness. Saturn's moon Titan offers the only other world in the solar system where you could walk outside with just an oxygen mask and thermal suit. No pressure suit required, as its atmospheric pressure is 1.5 times Earth's. Imagine landing near Kraken Mare, a methane sea larger than the Caspian Sea, where liquid methane waves lap against shorelines of water ice harder than granite at -179 degrees Celsius. NASA and ESA's Cassini-Huygens mission, with Huygens landing on Titan in 2005, revealed river channels, lakes, and weather patterns driven by methane instead of water. The moon's atmosphere is 95% nitrogen, thicker than Earth's, creating an orange haze that blocks visible light but allows radar to map vast dune fields covering 20% of the surface. A day on Titan lasts 15.9 Earth days, and the methane cycle mirrors Earth's water cycle, with rain, rivers, lakes, and seas. Scientists discovered in 2008 that Titan's lakes contain ethane, propane, and dissolved nitrogen, with some completely filled with liquid hydrocarbons hundreds of meters deep. This reminds us that familiarity can emerge from alien chemistry, that another world can have beaches and rain and seasons without resembling Earth in any fundamental way. Uranus's moon Miranda would provide the most dramatic bedroom view in the solar system, where you'd camp near Verona Rupes, a cliff face 20 kilometers high, 10 times deeper than the Grand Canyon. Picture standing at the edge where you could jump off and fall for 12 minutes before hitting the bottom due to Miranda's weak gravity. Though you'd reach only 200 kilometers per hour rather than terminal velocity. Voyager 2's 1986 flyby revealed that Miranda's surface appears to be a patchwork of different terrains, leading scientists to theorize the moon was shattered by an impact and reassembled, its pieces fusing back together imperfectly. The moon's corona features, chevron-shaped grooves covering its surface, remain unexplained, possibly caused by tidal heating or upwelling of less dense material. Your habitat would experience a day lasting 1.4 Earth days, with Uranus appearing 15 times larger in the sky than our moon appears from Earth. Temperatures hover around -213 degrees Celsius, and the surface is a mixture of water, ice, and rock with dark carbonaceous material. To think that this small world, only 471 kilometers in diameter, might have an ocean beneath its fractured crust, warmed by the same tidal forces that created its chaotic surface geology. Neptune's moon Triton orbits backward at 4.39 kilometers per second, the only large moon in the solar system with a retrograde orbit, suggesting it was captured from the Kuiper belt rather than forming alongside Neptune. Imagine your outpost positioned near active cryovolcanoes that erupt nitrogen gas and ice particles 8 kilometers into the thin atmosphere, creating dark streaks across the pinkish ice surface. Voyager 2 discovered in 1989 that Triton has the coldest surface temperature measured in the solar system at -235 degrees Celsius, yet remains geologically active. The moon's surface is young, with few impact craters. Covered instead in cantaloupe terrain, a pattern of dimpled and ridged features found nowhere else. A day on Triton lasts 5.9 Earth days, tidally locked to Neptune, and the Moon's orbit is gradually decaying, meaning it will be torn apart by tidal forces in 3.6 billion years, creating a ring system more spectacular than Saturn's. Scientists detected nitrogen ice geysers in 1989, powered by seasonal heating from the distant Sun, proving that even at 30 times Earth's distance from the Sun, solar energy can drive geological processes. In a sense, Triton represents borrowed time made visible, a captured world counting down to its own transformation into cosmic jewelry. Ceres, the largest object in the asteroid belt at 940 kilometers in diameter, was reclassified as a dwarf planet in 2006 and would offer a low-gravity, sleeping experience where you'd weigh only 3% of your Earth weight. Picture your habitat near Akator crater, where bright spots called facula shine from deposits of sodium carbonate, material that formed from briny water reaching the surface. NASA's Dawn spacecraft orbited Ceres from 2015 to 2018, discovering that the dwarf planet has a differentiated interior with a rocky core, an icy mantle, and possibly a subsurface ocean of briny water 40 kilometers deep. The bright deposits in Akator crater, called Cerealia facula and Vinalia faculae, are less than 4 million years old, indicating recent geological activity. A day on Ceres lasts only 9 hours and 4 minutes, making it spin faster than Earth despite its small size. Dawn detected organic molecules, water ice on the surface, and clay minerals that require water to form, suggesting Ceres might have had a warmer, wetter past. To rest on a world that represents the transition between rocky planets and icy bodies, where water and rock mixed in proportions that created something neither fully terrestrial nor completely frozen. Pluto's moon Charon, discovered in 1978 by James Christie at the US Naval Observatory, is so large relative to Pluto that the two orbit a barycenter, located in space between them, 960 kilometers above Pluto's surface. Imagine camping in Mordor Macula, a dark polar region colored by organic compounds called tholins, watching Pluto hang motionless in the sky since Charon is tidally locked with one hemisphere always facing its parent. New Horizons revealed in 2015 that Charon has a young surface with few craters, suggesting geological activity within the past 2 billion years, with massive canyons like Serenity Chasma stretching 1,800 kilometers. The reddish-brown coloring at Charon's North Pole comes from methane escaping from Pluto's atmosphere, freezing onto Charon, and being chemically altered by ultraviolet sunlight over millions of years. A day on Charon lasts 6.4 Earth days, identical to Pluto's rotation, meaning the same face of each world always looks at the other. Dorothy crater and Vulcan Planitia show evidence that Charon once had a subsurface ocean that froze and expanded, cracking the surface like a shell. This reminds us that even in the solar system's coldest reaches, where sunlight delivers barely more energy than starlight, worlds can still reshape themselves, still hold on to secrets beneath their frozen surfaces. Makemake, the second brightest dwarf planet in the Kuiper Belt after Pluto, discovered in 2005 by a team at Palomar Observatory, would provide a sleeping spot where methane frost covers the surface in bright patches. Picture your habitat on reddish terrain, where temperatures reach -243 degrees Celsius, making it one of the coldest known objects in the solar system. Observations from the Herschel Space Observatory in 2012 revealed that Makemake has no significant atmosphere, unusual for a Kuiper Belt object of its size. The dwarf planet measures 1,430 kilometers in diameter and completes one rotation every 22.5 hours, giving you an almost Earth-like day-night cycle. In 2016, astronomers using the Hubble Space Telescope discovered a small moon orbiting Make, nicknamed MK2, about 160 kilometers wide and darker than charcoal. Spectroscopic analysis shows Make's surface contains frozen methane, ethane, and possibly nitrogen, with brightness variations suggesting different surface compositions in different regions. To close your eyes on a world so distant that the sun appears merely as the brightest star, where your entire civilization's history would represent only a tiny fraction of the time it takes this frozen realm to complete one orbit. Orcus, discovered in 2004 at Palomar Observatory, orbits the Sun in almost exactly the same period as Pluto, 247 years, leading astronomers to call it Pluto's anti-twin, since it reaches opposite positions in their shared orbital path. Picture your shelter on water ice mixed with crystalline hydrated minerals, where spectroscopic observations from the Spitzer Space Telescope in 2009 revealed the surface contains frozen water, methane, and ammonia. The dwarf planet measures 917 kilometers in diameter and has one known moon, Vanth, discovered in 2005, which is unusually large relative to Orcus at 443 kilometers wide, making them nearly a binary system like Pluto and Charon. A day on Orcus lasts approximately 13.2 hours based on light curve analysis, and surface temperatures hover around minus 238 degrees Celsius. The density measurements suggest Orcus has a rocky core comprising 60% of its mass, surrounded by a thick ice mantle. Observations in 2010 detected crystalline water ice on the surface, which transforms to amorphous ice over millions of years under cosmic ray bombardment, suggesting recent geological activity or cryovolcanism. This reminds us that the outer solar system contains not one but multiple Pluto-like worlds, each following its own ancient dance, each harboring secrets about the solar system's formation locked in ice that predates life on Earth. Quaoar, discovered in 2002 and named after a creation deity of the Tongva people native to the Los Angeles area, surprised astronomers in 2007 when Hubble observations revealed crystalline ice on its surface. Imagine resting on terrain where fresh ice exists despite surface temperatures of minus 220 degrees Celsius and bombardment by cosmic rays that should have turned all crystalline ice amorphous millions of years ago. The dwarf planet measures 1,121 kilometers in diameter and orbits the Sun every 288 years at a distance that varies between 42 and 45 astronomical units. In 2007, scientists discovered Quaoar has a moon named Wat, 170 kilometers wide, orbiting every 12.4 days. The most shocking discovery came in 2023 when astronomers detected a ring system around Quaoar, located at a distance of 4,100 kilometers from its center, far beyond the Roche limit, where rings shouldn't be able to exist without coalescing into a moon. A day on Quaoar lasts 17.68 hours, and spectroscopic analysis detected not just water ice, but also methane ice, ethane, and complex organic molecules on the surface. To think that this distant world maintains crystalline ice through some unknown mechanism, possibly cryovolcanism or internal heating, challenging our understanding of what small, frozen worlds should be capable of doing. Gonggong, discovered in 2007 and named after a Chinese water god, ranks as one of the reddest objects in the outer solar system, with a color rivaling Mars due to complex organic compounds called tholins covering its surface. Picture your habitat on this dark red world, measuring 1,230 kilometers in diameter, where methane exposed to cosmic radiation over eons has transformed into reddish organic material. The dwarf planet follows a highly elliptical 554-year orbit that takes it from 33 to 101 astronomical units from the Sun, currently located near its most distant point. In 2016, astronomers discovered Gonggong has a moon named Shanglu, approximately 100 kilometers wide, orbiting every 25 days. Observations from the Hubble Space Telescope in 2010 and follow-up studies revealed the surface contains water ice and methane ice, with the methane being continuously processed by radiation into the reddish tholins. A day on Gonggong lasts approximately 22.4 hours, giving you an almost Earth-like circadian rhythm in this frigid realm. The dwarf planet's rotation axis is tilted at an extreme angle, possibly from an ancient collision that also created its moon. In a sense, Gonggong's deep red color tells a story written in chemistry, where millions of years of cosmic ray bombardment have painted this world in shades that make it visible across billions of kilometers. 16 Psyche, discovered in 1852 by Italian astronomer Annibale de Gaspares, might be the exposed metallic core of a protoplanet that lost its rocky outer layers in ancient collisions. Picture your habitat on a surface that radar observations suggest is 30 to 60% exposed iron-nickel metal, making it potentially worth $10,000 quadrillion if anyone could mine it. The asteroid measures 226 kilometers at its widest point and orbits the Sun. Every 5 years in the main asteroid belt between Mars and Jupiter. NASA's Psyche mission, launched in 2023, will arrive in 2029 to study this metal world with instruments that can map its composition and magnetic field. A day on Psyche lasts only 4.2 hours, and surface temperatures vary from -173 degrees Celsius to -73 degrees Celsius, depending on solar exposure. Recent observations in 2020 challenged earlier assumptions, suggesting Psyche might contain more rocky silicates than pure metal, possibly making it a primitive body that never fully differentiated. To close your eyes on what might be the remnant core of a failed planet, touching metal that formed in the violent early solar system when collisions built and destroyed worlds, when the architecture of our cosmic neighborhood was still being written in fire and impact. 433 Eros, discovered in 1898 by German astronomer Gustav Witt, became the first asteroid orbited by a spacecraft when NASA's Near Shoemaker probe arrived in 2000 and later landed on its surface. Imagine your sleeping bag anchored to a peanut-shaped rock 34.4 kilometers long, where boulders the size of houses rest in craters and grooves run across the surface like scars. The Near mission discovered that Eros is a solid, undifferentiated body rather than a rubble pile, with a density suggesting a composition of ordinary chondrite minerals similar to the most common meteorites that fall to Earth. A day on Eros lasts 5.27 hours, and the asteroid's orbit brings it close to Earth every 81 years, though it never comes closer than 22 million kilometers. Scientists analyzing NEA's data discovered that Eros has a layer of regolith, pulverized rock, at least 100 meters deep in some places, created by billions of years of micrometeorite impacts. The asteroid's surface shows evidence of space weathering, where solar, wind, and cosmic rays have chemically altered the outer layer, darkening it and changing its spectral signature. This reminds us that even a small rock in space has a history, that every crater and groove tells a story of impacts stretching back 4.5 billion years. 243 IDA, discovered in 1884 by Austrian astronomer Johann Palisa, made headlines in 1993 when NASA's Galileo spacecraft discovered it has a tiny moon named Dactyl, the first confirmed asteroid satellite. Picture resting on this irregularly shaped rock 54 kilometers long, watching its 1.4 kilometer moon orbit every 27 hours at a distance of 108 kilometers. The discovery of Dactyl proved that asteroids could have moons, revolutionizing understanding of asteroid formation and evolution. Galileo's images revealed Ida is an S-type asteroid composed of silicate rock and iron-nickel metal, with a heavily cratered surface indicating great age. A day on Ida lasts 4.63 hours, and the asteroid belongs to the Coronis family, a group of asteroids that formed from a catastrophic collision hundreds of millions of years ago. Surface features include numerous craters larger than 100 meters, with some showing rays of bright material ejected during impacts. Scientists believe Dactyl formed either during the collision that created Ida or through debris reaccumulation after a subsequent impact. To sleep on a world small enough to walk across in a day, yet still possessing enough gravity to hold a moon, challenges our intuitions about what constitutes a system, about where we draw the line between a rock and a world. Gaspra, discovered in 1916 by Russian astronomer Gregory Newman, became the first asteroid ever photographed up close when Galileo flew past in 1991 during its journey to Jupiter. Imagine your habitat on this potato-shaped rock, 18 kilometers long, where the surface is younger than expected, covered in relatively few craters compared to other asteroids of similar age. The images revealed Gaspra has a complex surface with grooves and ridges, possibly caused by shock waves from impacts or by internal fracturing. Spectroscopic analysis shows Gaspra is an S-type asteroid rich in silicate minerals and metal, with a surface that appears blue-gray in color-enhanced images. A day on Gaspra lasts approximately 7 hours based on brightness variations observed before the flyby. Scientists discovered the asteroid is covered in regolith, varying from fine dust to meter-sized rocks, with some faces showing evidence of relatively recent impacts that exposed fresh material. The relatively smooth appearance in some regions suggests Gaspra might be younger than 4 billion years, possibly a fragment from a larger body that broke apart more recently in asteroid belt history. In a sense, Gaspra represents a threshold moment in human exploration, the first time we saw an asteroid as a world rather than a point of light. When these wandering mountains became real places we might someday visit. Itokawa, discovered in 1998 and named after Japanese rocket pioneer Hideo Itokawa, became the first asteroid from which samples were deliberately collected and returned to Earth by Japan's Hayabusa mission in 2010. Picture your sleeping platform on this tiny rubble pile, just 535 meters long, assembled from fragments held together by minimal gravity, where you could leap into orbit with a good running start. The mission revealed Itokawa has two distinct terrains: rough, boulder-covered regions and smooth areas filled with small particles. Nicknamed the head and body of this peanut-shaped asteroid, analysis of returned samples confirmed Itokawa's composition matches ordinary chondrite meteorites, rocks relatively depleted in metallic iron. A day on Itokawa lasts 13 hours, and the asteroid's surface temperature varies from -43 degrees Celsius to 127 degrees Celsius, depending on sun exposure. Scientists discovered the smooth regions are caused by seismic shaking from impacts. which makes smaller particles migrate to gravitational lows, a process called Brazil nut effect. The asteroid's interior appears to be porous, with 40% empty space, confirming it's a gravitationally rebound rubble pile from a catastrophic collision. To rest on a world so small that standing on it would give you a horizon just meters away, where the sky is always black and Earth appears as a bright blue star in the unchanging cosmos. Bennu, discovered in 1999 and visited by NASA's OSIRIS-REx mission from 2018 to 2021, is a carbonaceous asteroid 492 meters wide that might contain organic molecules and hydrated minerals from the early solar system. Imagine anchoring your sleeping module to this spinning top-shaped body, where surface particles occasionally leap into space and fall back down in slow motion due to the asteroid's weak gravity. The mission discovered Bennu is ejecting particles from its surface, possibly due to meteorite impacts, thermal stress fracturing, or release of water vapor, making it an active asteroid despite having no atmosphere. A day on Bennu lasts 4.3 hours, and the asteroid's shape results from rapid rotation that has accumulated material around its equator over millions of years. In 2020, OSIRIS-REx collected samples from a crater named Nightingale and returned them to Earth in 2023, delivering 121.6 grams of pristine material. Scientists discovered Bennu's surface is much darker than expected, with an albedo of just 4.4% and covered in boulders where smooth regolith was anticipated. The asteroid has a 1 in 2,700 chance of impacting Earth in the late 22nd century, making it one of the most potentially hazardous known asteroids. This reminds us that some worlds we visit might someday visit us, that the line between exploration and planetary defense can blur when dealing with these wandering mountains of the inner solar system. On asteroid 21, Lutetia, your tent would rest on a battered surface covered in a thick blanket of regolith, an ancient world that Rosetta photographed during its flyby in July 2010. Picture anchoring your sleeping platform on metallic grey terrain pockmarked with craters, where this 100-kilometer wide asteroid shows evidence of being one of the oldest surviving objects in the solar system. The European Space Agency's Rosetta spacecraft revealed Lutetia has a surprisingly high density of 3.4 grams per cubic centimeter, suggesting a metallic interior possibly similar to Earth's core. A day on Lutetia lasts approximately 8.17 hours, and surface temperatures vary from -193 degrees Celsius in shadow to -3 degrees Celsius in sunlight. Scientists analyzing Rosetta's data in 2011 discovered Lutetia might be a planetesimal, a leftover building block from when planets were forming 4.5 billion years ago. The asteroid's surface shows a complex geological history with regions of different ages, some areas appearing to be over 3.6 billion years old. In a sense, sleeping on Lutetia means resting on a time capsule from the solar system's violent birth, when worlds collided and merged to build the planets we know today. On asteroid Vesta, your habitat would sit on the second largest object in the asteroid belt at 525 kilometers in diameter, where you could hike to Rhea Silvia crater, an impact basin so massive it covers most of the southern hemisphere. Imagine camping inside a crater 505 kilometers wide, with walls 20 kilometers high and a central peak rising 22 kilometers above the crater floor, taller than Olympus Mons on Mars measured from base to summit. NASA's Dawn spacecraft orbited Vesta from 2011 to 2012, discovering that this asteroid is actually a protoplanet that nearly became a full planet before. Jupiter's gravity disrupted the asteroid belt. A day on Vesta lasts only 5.34 hours, making it spin faster than Earth despite being much smaller, and surface temperatures vary from -190 degrees Celsius in shadow to -20 degrees Celsius in sunlight. The mission revealed that Vesta has a differentiated interior with an iron core, a rocky mantle, and a basaltic crust, making it similar in structure to Earth, Mars, and other terrestrial planets. Scientists analyzing meteorites discovered that a class called head meteorites, which have been falling to Earth for millions of years, actually came from Vesta, ejected by ancient impacts. This reminds us that pieces of Vesta have been visiting Earth long before humans existed. That fragments of this protoplanet burned through our atmosphere as shooting stars while dinosaurs walked below, carrying samples from a world that almost became a planet. Your tent on asteroid Hygeia, the fourth largest object in the main belt at approximately 434 kilometers in diameter, would rest on a surprisingly spherical surface for an asteroid, dark and ancient, picture-setting camp on terrain that reflects only 5.5% of sunlight among the darkest surfaces in the asteroid belt, where the nearly perfect spherical shape earned Hygeia consideration for dwarf planet status. Italian astronomer Annibale de Gasparis discovered Hygeia in 1849 from Naples Observatory, naming it after the Greek goddess of health. A day on Hygeia lasts approximately 27.6 hours based on light curve observations, giving you an almost Earth-like day-night cycle. Observations from ESO's Very Large Telescope in 2019 revealed that Hygeia is more spherical than previously thought, with a shape that meets the requirements for hydrostatic equilibrium. The asteroid orbits the Sun every 5.6 years at a distance averaging 3.14 astronomical units, residing in the outer main asteroid belt. Spectroscopic analysis shows Hygeia is a carbonaceous C-type asteroid, primitive and largely unchanged since the solar system's formation, with a surface rich in carbon compounds and likely containing significant water ice beneath a dark regolith layer. Scientists believe Hygeia might be the parent body of one of the largest asteroid families, created when a catastrophic collision shattered a larger object, and Hygeia is the largest surviving fragment. To close your eyes on a world balanced between asteroid and dwarf planet, where the borderline between categories blurs, where an object this size managed to pull itself into a sphere through its own gravity yet never quite became massive enough to clear its orbital neighborhood. Sleeping on asteroid Davida, the fifth largest in the main belt at approximately 357 kilometers across at its longest axis, would place you on an elongated C-type asteroid with a rotation so slow you'd experience a 5.13-hour day. Imagine your sleeping module on dark carbonaceous terrain where surface temperatures vary between -168 degrees Celsius and -108 degrees Celsius, depending on solar exposure and rotation. American astronomer Raymond Smith Duggan discovered Davida in 1903 at Heidelberg Observatory, and the asteroid orbits the Sun every 5.63 years at an average distance of 3.18 astronomical units. Observations from multiple telescopes suggest Davida has an irregular, somewhat elongated shape rather than being spherical, and its surface shows evidence of a thick regolith layer built up from billions of years of micrometeorite impacts. The asteroid's low density of approximately 1.3 grams per cubic centimeter indicates a porous, fragmented interior, possibly a rubble pile held together by gravity rather than a solid, monolithic rock. Spectroscopic studies detected phyllosilicates and possibly organic compounds on Davida's surface, materials that formed in the presence of liquid water, suggesting this asteroid or its parent body experienced aqueous alteration early in solar system history. Scientists estimate Davida contains enough water locked in minerals that if extracted and melted, it would equal several percent of the asteroid's total mass. In a sense, Davida represents a reservoir of ancient water frozen in minerals and buried beneath black dust. Water that existed before Earth's oceans formed, before the first raindrop ever fell on our planet's young crust. Your habitat on asteroid Interamnia, the sixth largest main belt asteroid at approximately 326 kilometers in diameter, would sit on a surface so dark it reflects only 5.8% of incoming sunlight. Picture camping on this F-type asteroid where spectroscopic observations suggest a composition rich in carbon and organic compounds, possibly with a surface layer containing clays that formed through interaction with water billions of years ago. Italian astronomer Vincenzo Cerulli discovered Interamnia in 1910 at Calirania Observatory in Tehemo, Italy, naming it after the Latin name for the nearby city. A day on Interamnia lasts 8.73 hours based on light curve analysis, and the asteroid follows a relatively circular orbit that takes 5.35 years to complete at an average distance of 3.06 astronomical units from the Sun. The asteroid appears to have a somewhat spherical shape, though not quite round enough to qualify as a dwarf planet under current definitions. Surface temperatures are estimated to average around -150 degrees Celsius, cold enough that any water ice in shadowed craters would remain stable for billions of years. Scientists analyzing Interamnia's spectral signature discovered it shows characteristics intermediate between C-type and B-type asteroids, suggesting a complex composition possibly resulting from thermal processing early in its history. The asteroid is likely differentiated to some degree, having heated up enough in the early solar system to allow denser materials to sink toward the center, to rest on a world that occupies a compositional middle ground, neither purely primitive nor fully evolved. A body that experienced just enough heat to begin changing but not enough to completely transform. Frozen mid-metamorphosis for 4.5 billion years. On Comet Halley, your anchored sleeping platform would need to grip the peanut-shaped nucleus measuring 15 kilometers long and 8 kilometers wide, covered in some of the darkest material in the solar system. Imagine camping on a surface that reflects only 4% of sunlight, darker than coal, where jets of water vapor, dust, and organic molecules erupt as the comet approaches the Sun. Edmund Halley calculated in 1705 that comet sightings from 1531, 1607, and 1682 were actually the same object returning every 75 to 76 years. And the comet was named in his honor after it returned as predicted in 1758. A day on Halley lasts approximately 52.8 hours, and ESA's Giotto spacecraft flew within 596 kilometers of the nucleus in 1986, revealing a heavily cratered surface with active regions covering only 10% of the total area. The nucleus has an extremely low density of 0.6 grams per cubic centimeter, indicating it's highly porous, possibly 75 to 80% empty space, like a cosmic snowball mixed with dust and held together loosely. Surface temperatures during Giotto's encounter ranged from 30 to 130 degrees Celsius on the sunlit side, hot enough to vaporize water, ice, and release gas at rates up to 20 tons per second. Scientists analyzing data from multiple Halley encounters discovered the nucleus contains complex organic molecules including formaldehyde and hydrogen cyanide, with the dark coating created by radiation processing of these organics over millions of years. to close your eyes on a world that returns like clockwork, that has been witnessed by humans for over 2,000 years, mentioned in Chinese records from 240 BCE, depicted in the Bayeux tapestry showing the Norman conquest of England, a cosmic timekeeper that connects generations across millennia through its predictable visits to the inner solar system. Your bedroom on asteroid 2867 Steins would perch on a diamond-shaped rock just 5 kilometers across, covered in craters that give it the appearance of a cosmic gemstone. Imagine camping near the massive crater on its southern hemisphere, 2.1 kilometers wide, which dominates nearly half the asteroid's surface. Rosetta flew past Steins on September 5, 2008, at a distance of just 800 kilometers. Capturing images that revealed this E-type asteroid reflects light unusually well due to its composition. The flyby discovered that Steins is covered in a layer of fine regolith, punctured by at least 23 craters larger than 200 meters, suggesting a violent collision history. A day on Steins lasts approximately 6 hours based on brightness variations observed during Rosetta's approach. The asteroid's surface appears to be made of silicate minerals poor in iron, giving it a lighter color than most asteroids, and possibly containing enstatite, a mineral found in some rare meteorites. Scientists believe the large southern crater was created by an impact so powerful it nearly shattered Steins completely, and smaller secondary craters formed from debris falling back to the surface. To close your eyes on this tiny world means resting on a survivor, a fragment that refused to be destroyed, that absorbed a planet-killing blow and somehow remained whole. Sleeping on Saturn's moon, Mimas, would place you in the shadow of Herschel crater, a 139-kilometer impact scar so large it gives the moon an uncanny resemblance to the Death Star from Star Wars. Picture your habitat, positioned where you could watch Saturn fill a third of the sky, its rings appearing edge-on or face-on, depending on the season. While this 396-kilometer wide moon completes one orbit every 22.6 hours, British astronomer William Herschel discovered Mimas in 1789, and NASA's Voyager 1 spacecraft revealed Herschel crater in 1980, an impact that came close to shattering the entire moon. The crater is 10 kilometers deep, with a central peak rising 6 kilometers above the crater floor, and shockwaves from the impact created fractures on the opposite side of Mimas. A day on Mimas matches its orbital period due to tidal locking, and surface temperatures average -200 degrees Celsius, with some variation between day and night sides. Scientists discovered in 2014 that Mimas's orbit wobbles slightly, suggesting either an elongated core or possibly a subsurface ocean 24 to 31 kilometers beneath the ice, though this remains controversial. This reminds us that even the most heavily scarred worlds might hide oceans beneath their frozen crusts, that catastrophic violence and the possibility of liquid water can coexist in the same small moon. Your sleeping quarters on Saturn's moon, Enceladus, would need thermal shielding from the ice geysers erupting just kilometers away, shooting water, ice particles, and organic molecules 500 kilometers into space. Imagine camping in a region near the South Pole where parallel fractures called tiger stripes glow with infrared heat, warm enough that subsurface temperatures reach -90 degrees Celsius compared to the moon's average surface temperature of -201 degrees Celsius. NASA's Cassini spacecraft discovered these geysers in 2005, detecting water vapor, ice grains, salts, silica particles, and complex organic molecules including methane and formaldehyde. The moon measures only 504 kilometers in diameter, Yet the geysers feed Saturn's E-ring with fresh ice particles continuously, replacing material lost to space. A day on Enceladus lasts 32.9 hours, tidally locked to Saturn, and the moon's icy surface reflects 99% of incoming sunlight, making it the most reflective body in the solar system. Cassini's flybys between 2008 and 2015 detected molecular hydrogen in the plume material, suggesting hydrothermal vents on the ocean floor interact with rocky material, creating conditions potentially suitable for life. To rest, knowing that beneath you lies a global ocean 10 kilometers deep, kept liquid by tidal heating from Saturn's gravity, where water touches rock in darkness that has never seen the sun. On Jupiter's moon, Io, your reinforced bunker would need to withstand constant seismic activity from the most volcanically active body in the solar system, where approximately 400 volcanoes erupt simultaneously. Picture watching Loki Patera, a lava lake 200 kilometers across that erupts with more power than all of Earth's volcanoes combined, while sulfur dioxide frost sublimates around you in yellow, white, red, and black patterns. NASA's Voyager 1 discovered Io's volcanism in 1979 when navigation engineer Linda Morabito noticed a plume 300 kilometers high in a departure image. The moon measures 3,643 kilometers in diameter, slightly larger than Earth's moon, and completes one orbit around Jupiter every 42.5 hours while locked in orbital resonance with Europa and Ganymede. Surface temperatures vary wildly from -163 degrees Celsius in shadowed areas to 1,327 degrees Celsius near active lava flows, making Io's surface the most temperature variable in the solar system. Galileo spacecraft observations from 1995 to 2003 revealed that Io's volcanism is driven by tidal heating, as Jupiter's massive gravity flexes the moon's interior, generating 100 trillion watts of heat. In a sense, Io represents what happens when a world becomes trapped in a gravitational wrestling match, stretched and squeezed so constantly that its interior never cools, never rests, never stops, melting and erupting in an endless volcanic dance. Your habitat on Jupiter's moon, Ganymede, would sit on the largest moon in the entire solar system, bigger than Mercury, where you'd be the first human to sleep on a world with its own magnetic field, aside from Earth. Imagine establishing camp in the bright, grooved terrain of Uruk Sulcus, where parallel ridges and valleys stretch for hundreds of kilometers, created by tectonic processes that resurfaced 40% of Ganymede's surface. Galileo Galilei discovered Ganymede on January 7, 1610. Observing it with his primitive telescope alongside Io Europa and Callisto, the four largest Jovian moons now called the Galilean satellites. The moon measures 5,268 kilometers in diameter, 8% larger than Mercury, yet only 45% as massive due to its composition of roughly equal parts rock and water ice. A day on Ganymede lasts 15 Earth days, tidally locked to Jupiter. And NASA's Galileo spacecraft discovered in 1996 that Ganymede generates a magnetic field, the only moon known to do so, suggesting a liquid iron core. Hubble Space Telescope observations in 2015 detected evidence of a subsurface ocean containing more water than all of Earth's oceans, buried beneath 150 kilometers of ice. To close your eyes on a moon that functions almost like a miniature planet, complete with a metallic core, internal layers, a magnetic field, and auroras dancing at its poles in ultraviolet light, invisible to human eyes. Sleeping on Jupiter's moon, Callisto, would place you on the most heavily cratered object in the solar system. A world that appears unchanged since the late heavy bombardment 4 billion years ago. Picture your shelter near Valhalla, a multi-ring impact basin 3,800 kilometers across. So ancient and large that its concentric ridges make the surface resemble a target that absorbed countless cosmic bullets. Galileo Galilei discovered Callisto on January 7, 1610. The same night he first observed Ganymede, and the moon measures 4,821 kilometers in diameter, almost exactly the same size as Mercury. A day on Callisto lasts 16.7 Earth days, and NASA's Galileo spacecraft revealed between 1996 and 2003 that beneath the ancient cratered crust lies a subsurface ocean 100 to 200 kilometers deep. Surface temperatures average minus 139 degrees Celsius, and Callisto's low density of 1.83 grams per cubic centimeter suggests it never fully differentiated into distinct layers like other large moons. The Galileo mission detected changes in Callisto's magnetic field, indicating a salty ocean interacts with Jupiter's magnetosphere, similar to Europa but buried much deeper. Scientists believe Callisto's lack of geological activity resulted from its distance from Jupiter, where tidal heating never melted its interior enough to trigger the volcanism seen on Io or the tectonic activity on Ganymede and Europa. This reminds us that sometimes the quiet worlds are the most informative, that a surface frozen in time for billions of years can tell us more about the early solar system than any geologically active world constantly erasing its own history. Your tent on Saturn's moon Iapetus would straddle the boundary between two entirely different worlds. One side bright as snow, reflecting 50% of sunlight. The other side dark as asphalt, absorbing 96%, creating the most extreme color contrast in the solar system. Imagine camping along the equatorial ridge, a mountain chain 20 kilometers high and 1,300 kilometers long that circles exactly along Iapetus's equator, a feature found nowhere else that makes the moon resemble a walnut. Giovanni Cassini discovered Iapetus in 1671. Noticing it appeared bright on one side of Saturn and nearly invisible on the other. A mystery that wasn't solved until the Cassini spacecraft arrived in 2004. The moon measures 1,469 kilometers in diameter and orbits Saturn every 79.3 Earth days at a distance of 3.56 million kilometers, far enough that it's not tidally locked to Saturn but rather to the Sun. A day on Iapetus lasts 79.3 Earth days, identical to its orbital period, meaning one hemisphere always leads as the moon orbits Saturn, constantly bombarded by dark material, while the trailing hemisphere remains pristine white. The Cassini mission revealed in 2007 that the dark material, called Cassini Regia, consists of carbon-rich compounds, possibly from cometary impacts or erupted from the interior, and sublimation of water ice from dark regions makes them darker over time as impurities concentrate. Scientists discovered that the equatorial ridge likely formed when Iapetus was spinning much faster, completing a rotation every 16 hours, and the ridge froze in place as the moon's rotation slowed over billions of years. To sleep on a world that appears to be two moons fused together, where you could walk from permanent daylight into permanent darkness in just a few kilometers, where a mountain range taller than Olympus Mons circles the entire equator for reasons still being debated. Your habitat on dwarf planet Varuna would sit on a rapidly spinning, elongated world that completes one rotation every 6.34 hours, among the fastest rotation rates of any large object beyond Neptune. Picture your base on reddish terrain where the rapid spin has stretched Varuna into an ellipsoid shape, approximately 668 kilometers long and 475 kilometers wide. Robert Macmillan discovered Varuna at Spacewatch Observatory in 2000, making it one of the first large Kuiper Belt objects found after Pluto. The dwarf planet orbits the Sun every 283 years at distances between 41 and 45 astronomical units. Currently located in the classical Kuiper Belt, spectroscopic observations from Mauna Kea Observatory in 2001 revealed water ice on Varuna's surface, along with possible organic compounds that give it a reddish color. Surface temperatures average around -230 degrees Celsius, and Varuna's density is estimated at approximately 1.0 grams per cubic centimeter, suggesting a composition of mostly water ice with some rock. Scientists discovered that Varuna's rapid rotation and elongated shape indicate it might have experienced a massive collision that set it spinning, or possibly it formed from the merger of two objects. To close your eyes on a world spinning so fast that day and night cycle in less time than a work shift on Earth, where centrifugal force has molded the entire dwarf planet into a stretched oval, where the equator experiences noticeably less gravity than the poles due to the rotational velocity. On dwarf planet Salacia, your sleeping platform would rest on a surface covered in water ice mixed with dark material, part of a binary system where Salacia and its moon Actia are nearly equal in size. Imagine camping on this 854-kilometer world while watching Actia, measuring 286 kilometers across, orbit just 5,619 kilometers away every 5.49 days. Henry Rowe and colleagues discovered Salacia in 2004 at Palomar Observatory, and the discovery of its large moon in 2006 allowed precise mass calculations. A day on Salacia lasts approximately 6.1 hours based on light curve variations, making it another rapidly rotating Kuiper Belt object. The dwarf planet orbits the Sun every 271 years at a distance averaging 42 astronomical units, placing it in the classical Kuiper Belt region. Spectroscopic observations from Gemini Observatory detected water ice absorption features on both Salacia and Actia, along with possible methane and ammonia compounds. The system's combined mass is approximately 0.44% of Pluto's mass, and the similar sizes of the two objects suggest they might have formed from a collision or a disrupted larger body. Scientists calculating the system's density arrived at approximately 1.3 grams per cubic centimeter, indicating a mixture of ice and rock similar to many Kuiper Belt objects. In a sense, Salacia represents a miniature version of the Pluto-Charon system. Two worlds locked in mutual orbit, each tidally locked to always show the same face to its companion, dancing together through the frozen outer reaches where sunlight arrives 1,700 times dimmer than at Earth. Your tent on trans-Neptunian object Vardar would anchor near crystalline water ice formations, camping on a world where the surface composition suggests recent geological activity despite being 705 kilometers wide. Picture resting on terrain where observations from Gemini and Keck observatories detected not just water ice, but specifically crystalline water ice, which cosmic rays should convert to amorphous ice over millions of years. Michael Brown discovered Vardar at Palomar Observatory in 2003, and follow-up observations in 2009 revealed a small moon named Ilmaru, approximately 326 kilometers in diameter, orbiting every 5.75 days. A day on Vardar lasts roughly 7.87 hours, giving you a brief night-day cycle, and the binary system orbits the Sun every 313 years at distances between 41 and 48 astronomical units. Scientists analyzing near-infrared spectra discovered that Varda's crystalline ice signature is unusually strong, suggesting either internal heating, recent impacts exposing fresh ice, or cryovolcanism keeping the surface renewed. The system's total mass is approximately 0.26% of Pluto's mass, and density calculations suggest a composition similar to other mid-sized Kuiper Belt objects. Varda belongs to a dynamical class called resonant objects, locked in a 3 to 4 orbital resonance with Neptune, meaning Varda completes 3 orbits for every 4 Neptune makes. To close your eyes on a frozen world that somehow maintains young ice on its surface, where crystalline water sparkles in the dim sunlight billions of kilometers from Earth, where the mystery of what keeps the ice fresh remains unsolved, waiting for future missions to this distant realm. Sleeping on trans-Neptunian object Ixion would place you on a moderately red surface covered in tholins, complex organic molecules created when methane and other ices are bombarded by cosmic radiation. Imagine your habitat on this 617-kilometer world where observations suggest a surface composition of water ice mixed with carbon compounds, giving it a color similar to Mars but much darker. Cerro Tololo Inter-American Observatory astronomers discovered Ixion in 2001, making it one of the first large objects found in a new survey of the outer solar system. A day on Ixion remains uncertain, though preliminary observations suggest a rotation period somewhere between 12 and 20 hours. The object orbits the Sun every 250 years in a highly elliptical path that takes it from 30 to 49 astronomical units, meaning Ixion currently resides at approximately 40 times Earth's distance from the Sun. Spectroscopic analysis from multiple telescopes detected water ice, carbon compounds, and possibly methanol on the surface, with the reddish color intensifying over time as radiation processes organic materials. Surface temperatures average -235 degrees Celsius, and Ixion's density is estimated at approximately 1.5 grams per cubic centimeter, suggesting roughly equal parts rock and ice. Scientists believe Ixion was originally part of the scattered disk, gravitationally scattered by Neptune during the solar system's early reorganization before settling into its current orbit. This reminds us that color tells stories in the outer solar system, that red surfaces record millions of years of radiation chemistry, that every world wears the evidence of its exposure to cosmic rays like a badge, showing how long it has wandered the darkness. Your sleeping module on 2002 MS4, one of the largest unnamed Kuiper Belt objects at approximately 726 kilometers in diameter, would rest on a surface that remains largely mysterious due to its great distance and faintness. Picture camping on a world discovered by Chad Trujillo and Michael Brown at Palomar Observatory in 2002, orbiting the Sun every 270 years at distances between 36 and 48 astronomical units. A rotation period of approximately 8-9 hours has been tentatively measured through brightness variations, suggesting you'd experience relatively short days on this distant world. Limited spectroscopic observations hint at water ice and possibly methane on the surface, though detailed composition remains uncertain without closer study. Surface temperatures are estimated at -233 degrees Celsius, similar to other objects at this distance, and 2002 MS4 likely has a density around 1.0 to 1.5 grams per cubic centimeter based on size estimates. The object follows a relatively circular orbit in the classical Kuiper Belt, suggesting it formed near its current location rather than being scattered from elsewhere. Scientists consider 2002 MS4 a strong candidate for dwarf planet status once better size measurements and shape determinations become available. To rest on an unnamed world, one of dozens of large objects in the Kuiper Belt still awaiting detailed study, where your footprints would mark the first human contact with a world that existed in obscurity for 4.5 billion years. Noticed by telescopes only 2 decades ago, still waiting for its formal naming and classification. Your sleeping module on Uranus's moon, Ariel, would rest near massive canyons called chasmata, where fault scarps plunge 10 kilometers deep and stretch for hundreds of kilometers across the surface. Picture camping in Corrigan Chasma, where the valley floor appears to have been resurfaced by flows of icy material, possibly ammonial water mixtures that erupted from below when the moon was geologically active. William Lassell discovered Ariel in 1851, and Voyager 2's flyby in 1986 revealed that this 1,158-kilometer-wide moon has the brightest and possibly youngest surface of Uranus's 5 major moons. A day on Ariel lasts 2.5 to Earth days, tidally locked to Uranus, and surface temperatures average -213 degrees Celsius. The canyons show evidence of extension and normal faulting, suggesting Ariel's interior once froze and expanded, cracking the crust like an eggshell. Scientists analyzing Voyager 2 data discovered that many craters have been filled in or erased by the resurfacing events, and some valley floors show smoother material that might have been cryovolcanic flows of melted ice. To close your eyes in a valley carved by a moon's expansion, where ancient geological forces tore the surface apart and then healed the wounds with flows of exotic ices, where the sky shows Uranus as a pale blue sphere 4 times larger than our moon appears from Earth. On Uranus's moon, Umbriel, your habitat would need enhanced lighting to compensate for camping on the darkest major moon in the solar system, where the surface reflects only 16% of incoming light. Imagine establishing base near Wanda Crater, a mysterious, bright ring 131 kilometers across that stands out like a bullseye against the otherwise uniformly dark terrain. William Lassell discovered Umbriel on the same night in 1851 as Ariel, and the moon measures 1,169 kilometers in diameter, nearly identical in size to Ariel, yet completely different in appearance. A day on Umbriel lasts 4.1 for Earth days, and Voyager 2's 1986 flyby revealed an ancient, heavily cratered surface with no signs of geological activity, making it the most geologically dead of Uranus's major moons. Surface temperatures hover around -198 degrees Celsius, and the dark coloring likely comes from carbon-rich material coating the surface, possibly delivered by comet impacts over billions of years. The origin of Wanda Crater's bright floor remains unexplained, with theories ranging from relatively recent impact exposing fresh ice to frost deposits from outgassing. Scientists studying Voyager 2 images found that Umbriel has fewer large craters than expected, suggesting some ancient resurfacing event, yet the surface appears older than any other Uranian moon. This reminds us that not every world has a story of activity and change, that some moons simply exist in quiet darkness, their mysteries written in subtle brightness, variations across an ancient, unchanging face. Your sleeping bag on Uranus's moon Titania would anchor near Messina Chasmata, a canyon system that cuts through this largest Uranian moon's icy crust, showing evidence that Titania once had a subsurface ocean that froze and expanded. Picture resting on a world 1,577 kilometers in diameter, where Gertrude Crater, named after Hamlet's mother, spans 326 kilometers, with a bright ray system visible across hundreds of kilometers. William Herschel discovered Titania on January 11, 1787, using the same telescope he used to discover Uranus itself 6 years earlier. A day on Titania lasts 8.71 Earth days, tidally locked to Uranus. And Voyager 2's flyby revealed a surface that appears to have been resurfaced during some geological active period billions of years ago. Surface temperatures average -203 degrees Celsius, and the Moon's density of 1.71 grams per cubic centimeter suggests a composition of approximately 50% water ice and 50% rock. Scientists analyzing Voyager 2 data discovered enormous fault valleys cutting across Titania, some over 1,500 kilometers long, evidence that the Moon's interior froze and expanded by several percent, cracking the surface. The relatively few craters in some regions compared to others suggests different ages for different terrains, with some areas possibly as young as 1 billion years old. To think that beneath you once flowed a liquid ocean, now frozen solid and pressing outward against the crust with such force that it tore canyons into the ice. Permanent scars from a transformation that happened when Earth's surface was still dominated by single-celled life. Sleeping on Uranus's moon, Oberon, would place you among the most heavily cratered landscapes in the solar system, particularly near Hamlet Crater, a 206-kilometer impact basin with a bright central peak and dark material on its floor. Imagine your shelter positioned where you could observe Mama Chasma, a canyon that cuts across the Moon's eastern limb, and mysterious dark patches on several crater floors that might be cryovolcanic material that erupted from below. William Herschel discovered Oberon on January 11, 1787. The same night he discovered Titania, and at 1,523 kilometers in diameter. Oberon is the second largest and outermost of Uranus's major moons. A day on Oberon lasts 13.46 Earth days, the longest rotation period of any Uranian moon, and surface temperatures average -198 degrees Celsius. Voyager 2's 1986 flyby revealed that Oberon has the reddest surface of the Uranian moons, possibly due to ammonia ice mixed with darker material, and shows a heavily cratered terrain suggesting great age. The dark material on some crater floors appears to have welled up from the interior, evidence that Oberon was once geologically active with a liquid subsurface layer. Scientists discovered that one mountain near the Moon's limb rises approximately 11 kilometers high, though its exact height remains uncertain due to the single Voyager 2 flyby providing limited viewing angles. In a sense, Oberon represents a world that ceased changing billions of years ago, where every crater remains perfectly preserved, where the surface has become a museum of impacts recording the bombardment history of the outer solar system. Your tent on Neptune's moon Proteus would cling to the second largest moon orbiting closer to its planet than any other large satellite. A dark, irregularly shaped world 420 kilometers across that orbits just 4,750 kilometers above Neptune's cloud tops. Picture camping near Pharos crater, a depression so large relative to Proteus that scientists believe the moon is near the maximum size a body can be without collapsing into a sphere under its own gravity. Voyager 2 discovered Proteus in 1989 during its Neptune flyby, having been missed by Earth-based telescopes because it orbits so close to Neptune's glare. A day on Proteus lasts only 26.9 hours, and the moon's surface reflects just 6% of incoming sunlight, making it one of the darkest objects in the solar system, as black as asphalt. The surface shows numerous craters and ridges, but no signs of geological modification, suggesting Proteus is a captured object or a fragment from a larger moon destroyed by impact. Scientists analyzing Voyager 2 images discovered that Proteus's shape resembles a polyhedron with several flat faces, and Pharos crater is nearly 255 kilometers across, big enough that a more powerful impact might have shattered the entire moon. The extreme darkness of the surface suggests a composition rich in carbon compounds, possibly similar to the darkest asteroids or cometary nuclei, to rest on a world that exists at the edge of gravitational stability, where one more major impact might reduce it to rubble, where it orbits so close to Neptune that atmospheric drag will eventually cause it to spiral inward and either impact the planet or be torn apart by tidal forces in millions of years. Sleeping on Neptune's moon Nereid would mean camping on one of the most elliptical orbits in the solar system, where the moon's distance from Neptune varies from 1.4 million to 9.7 million kilometers during its 360-day orbit. Imagine resting on this 340-kilometer irregular moon where a single orbit takes nearly an Earth year, and the intensity of Neptune's appearance in your sky would change by a Pisa factor of 50 between closest and farthest approach. Gerard Kuiper discovered Nereid in 1949, and it remained Neptune's second known moon until Voyager 2 discovered 6 additional moons in 1989. A day on Nereid is uncertain, with estimates ranging from 11 to 14 hours based on brightness variations. But the moon is not tidally locked, tumbling chaotically as it orbits. Surface temperatures would vary dramatically during the orbit, from roughly minus 220 degrees Celsius at apopsis to minus 200 degrees Celsius at periapsis. Scientists believe Nereid was once a regular satellite or captured Kuiper belt object whose orbit was dramatically altered when Neptune captured Triton, the gravitational disruption throwing Nereid into its current eccentric path. The moon's light curve shows variations suggesting an elongated, irregular shape, possibly a fragment from a collision or simply a captured asteroid. This reminds us that not every orbit is stable, that gravitational interactions can throw worlds into paths that seem impossible, that Nereid spends most of its time far from Neptune, barely bound by gravity, forever falling toward the planet and then swinging away in an endless elliptical dance. Your sleeping bag on asteroid Juno, the 11th object ever discovered in the asteroid belt, would rest on stony terrain covering this irregularly shaped world, roughly 233 kilometers at its widest point. Imagine camping on a surface that German astronomer Carl Ludwig Harding first spotted on September 1, 1804, from Lilienthal Observatory, making Juno the third asteroid ever found after Ceres and Pallas. A day on Juno lasts 7.21 hours, and spectroscopic observations classify it as an S-type asteroid composed primarily of silicate rock and metallic iron, with a surface that reflects about 24% of sunlight, making it unusually bright for an asteroid. The surface temperature varies from minus 153 degrees Celsius to minus 73 degrees Celsius depending on rotation and distance from the Sun during its 4.36-year orbit. Observations from the Hubble Space Telescope and ground-based adaptive optics systems revealed that Juno has an irregular, elongated shape with a large crater or concavity on one side, possibly from an ancient impact. Scientists discovered that Juno is the source of a small asteroid family, with about 60 known members that share similar orbital characteristics, suggesting Juno experienced at least one major collision that ejected fragments. The asteroid's relatively high albedo and stony composition make it occasionally visible to the naked eye from Earth during favorable oppositions, a wandering point of light that ancient astronomers tracked without understanding what they were observing, to rest on a world that helped humans realize the asteroid belt existed. One of the keystones in our understanding that not everything in the solar system fits into the simple categories of planets and moons. A discovery that opened our eyes to the true complexity of our cosmic neighborhood. On asteroid Eunomia, your habitat would sit on the largest member of the Eunomia family, a stony Stipe asteroid approximately 255 kilometers in diameter that gave birth to an entire family of smaller asteroids. Picture your base on terrain where Italian astronomer Annibale de Gasparis discovered this world on July 29, 1851, from Naples Observatory, naming it after the Greek goddess of law and order. A day on Eunomia lasts only 6-8 hours, making it one of the faster rotating large asteroids, and it completes one orbit around the Sun every 4.3 years at an average distance of 2.64 astronomical units. Surface temperatures range from -163 degrees Celsius to -73 degrees Celsius, and the asteroid's relatively high reflectivity of 21% makes it occasionally visible with binoculars. During favorable oppositions, scientists analyzing the Eunomia family discovered over 5,000 smaller asteroids share similar orbital elements, all fragments from catastrophic collisions that struck the parent body hundreds of millions of years ago. Spectroscopic studies show Eunomia's surface contains olivine and pyroxene, common silicate minerals found in Earth's mantle, suggesting the asteroid might be a fragment from a larger differentiated body that was destroyed. The asteroid has an estimated mass of about 3.1 times yp kilograms, making it one of the more massive main belt asteroids. This reminds us that asteroid families are like cosmic forensic evidence, each family telling the story of a violent collision, each member carrying pieces of the shattered parent body, together forming a slow-motion explosion frozen across millions of kilometers of space and millions of years of time. Your tent on asteroid Euphrosyne, one of the darkest and largest asteroids at approximately 268 kilometers in diameter, would anchor to carbonaceous terrain that reflects only 5.6% of incoming sunlight. Imagine setting camp on this C-type asteroid where James Ferguson discovered it on September 1, 1854, from the United States Naval Observatory in Washington, D.C., naming it after one of the three Graces from Greek mythology. A day on Euphrosyne lasts 5.53 hours, and the asteroid follows a notably inclined orbit, tilted 26.3 degrees to the ecliptic plane, taking 5.6 years to circle the Sun at an average distance of 3.15 astronomical units. Surface temperatures average around -163 degrees Celsius, and spectroscopic analysis reveals a primitive composition rich in carbon compounds, water-bearing minerals, and organic molecules unchanged since the solar system's formation. Scientists discovered in 2019 that Euphrosyne is the largest member of one of the oldest asteroid families, with about 1,400 members created by a collision approximately 700 million years ago. The asteroid's low density of approximately 1.2 grams per cubic centimeter suggests a porous interior, possibly a rubble pile with significant empty space between fragments. Observations from the Spitzer Space Telescope detected that Euphrosyne's surface contains hydrated minerals, clays that could only form in the presence of liquid water, suggesting either the asteroid or its parent body experienced aqueous alteration early in solar system history. To close your eyes on one of the oldest collision remnants we can identify. on a fragment from an impact that occurred when Earth's continents were still assembling into the supercontinent Rodinia, when the most complex life forms were simple multicellular organisms, when the entire evolutionary story from fish to humans still lay in the unwritten future. Sleeping on asteroid Cybele, approximately 237 kilometers in diameter, would place you in the outer asteroid belt at 3.43 astronomical units from the Sun, camping on dark carbonaceous terrain of a world that gives its name to the Cybele group. Picture your habitat where French astronomer Wilhelm Tempel discovered this asteroid on March 8, 1861, from Marseille Observatory, naming it after the Phrygian mother goddess. A day on Cybele lasts approximately 6-8 hours, and the asteroid follows a nearly circular orbit that takes 6.34 years to complete. Residing in a region where orbital resonances with Jupiter keep objects in relatively stable paths, surface temperatures average around -173 degrees Celsius, colder than most main belt asteroids due to Cybele's greater distance from the Sun. Spectroscopic observations classify Cybele as a P-type or C-type asteroid, indicating a primitive composition with a very dark surface that reflects less than 5% of sunlight, possibly containing organic compounds and hydrated minerals. Scientists studying the Cybele group identified about 2,000 asteroids that share similar orbital characteristics, making it one of the major dynamical families in the outer main belt. The asteroid's density is estimated at approximately 1.4 grams per cubic centimeter, suggesting a composition of rock mixed with water, ice, and possibly a porous structure. Observations detected weak spectral features consistent with phyllosilicates, clay minerals that form when water interacts with rock, providing evidence that liquid water once existed within this asteroid or its parent body. In a sense, Cybele represents a transitional population between the rocky asteroids of the inner belt and the icy bodies of the outer solar system, objects that contain enough water to blur the distinction between asteroid and comet, between the warm inner regions and the frozen outer reaches. Your sleeping module on asteroid Bomberger, approximately 229 kilometers in diameter, would rest on one of the largest C-type asteroids, camping on dark terrain discovered by Johann Palisa on February 25, 1892, from Vienna Observatory. Imagine anchoring to a surface so dark it reflects only 5% of sunlight, where temperatures drop to -168 degrees Celsius during the 29.4-hour day, one of the longest rotation periods among large asteroids. The asteroid orbits the Sun every 4 years at an average distance of 2.68 astronomical units, following an orbit that brings it closer to Mars's orbit than most main-belt asteroids. Spectroscopic analysis reveals a primitive carbonaceous composition rich in organic compounds and hydrated minerals, with surface features suggesting the presence of phyllosilicates altered by water. Scientists analyzing Bamberger's light curve discovered irregular brightness variations indicating an elongated or irregular shape rather than a spherical body. The asteroid has an estimated mass of approximately 1.2 times 1018 kilograms and belongs to no identified asteroid family, suggesting it has survived intact since the solar system's formation without experiencing the catastrophic collisions that created family groups. Radar observations attempted in the 1990s and 2000s provided limited data due to Bamberger's distance and small size, leaving many questions about its surface features and internal structure unanswered. To rest on a solitary survivor, an asteroid with no known siblings. a world that somehow avoided being shattered during 4.5 billion years of impacts, that maintained its integrity while around it the asteroid belt became a shooting gallery of collisions, creating the families we observe today. On asteroid Pallas, the third largest object in the main belt at approximately 512 kilometers in diameter, your habitat would need to account for the most highly inclined major asteroid orbit, tilted 34.8 degrees to the ecliptic plane. Picture camping on terrain where German astronomer Wilhelm Olbers discovered this world on March 28, 1802, just 15 months after the discovery of Ceres, making Pallas the second asteroid ever found. A day on Pallas lasts 7.81 hours, and spectroscopic observations classify it as a B-type asteroid with a composition that remains puzzling, showing features of both carbonaceous and silicate-rich bodies. Surface temperatures vary from -173 degrees Celsius to -73 degrees Celsius, and the asteroid's surface reflects about 16% of incoming sunlight, brighter than most carbonaceous asteroids. Scientists analyzing observations from the Hubble Space Telescope and ground-based adaptive optics discovered that Pallas has a roughly spherical shape with several large impact basins, including one approximately 400 kilometers across, covering much of the southern hemisphere. The asteroid's unusual orbit, highly inclined and somewhat eccentric, means it experiences higher impact velocities from other asteroids than any other large body in the belt. Spectroscopic data detected evidence of water ice or hydrated minerals on Pallas's surface, and some researchers suggest the asteroid might be a protoplanet that formed in the outer asteroid belt and migrated inward. This reminds us that Pallas is the asteroid belt's wildcard, following rules that differ from its neighbors. Tilted at an angle that speaks of ancient gravitational encounters or formation conditions we don't fully understand. A massive world that refuses to conform to the patterns we observe in other asteroids. Your sleeping bag on asteroid Thisbe, approximately 232 kilometers in diameter, would rest on carbonaceous terrain discovered by Christian Peters on June 15, 1866, from Litchfield Observatory in New York. Imagine camping on this dark, C-type asteroid, where a day lasts 6.04 hours and surface temperatures hover around -158 degrees Celsius. The asteroid orbits the Sun every 4.6 years at an average distance of 2.77 astronomical units, following a relatively circular path in the middle of the main belt. Spectroscopic observations reveal a primitive surface composition containing carbon compounds, organic molecules, and hydrated minerals, with an albedo of only 6%, making it one of the darker large asteroids. Scientists analyzing Thisbe's rotation discovered a light curve with relatively small variations, suggesting a nearly spherical or only slightly elongated shape. The asteroid shows spectral features consistent with aqueously altered minerals, phyllosilicates that formed when liquid water reacted with rock in the asteroid's interior during the first few million years after formation. Thisbe has an estimated mass of approximately 8.9 times 1017 kilograms and shows no signs of belonging to any identified asteroid family, indicating it has survived intact as a primordial fragment since the solar system's youth. Observations from infrared surveys detected that Thisbe's surface layer appears to be covered in fine regolith, several meters deep, pulverized rock created by billions of years of micrometeorite bombardment. To close your eyes on a world whose darkness speaks of pristine organic chemistry, where the black surface contains molecules that predate life on Earth, where the clays in the regolith formed from water that existed when our solar system was younger than many human civilizations, when the Sun was still surrounded by the debris disk from which planets grew. Sleeping on asteroid Iris, one of the brightest asteroids at magnitude 7 during favorable oppositions, would place you on stony terrain approximately 214 kilometers in diameter that reflects an unusually high 27% of sunlight. Picture your habitat where John Hind discovered this E-type asteroid on August 13, 1847, from George Bishop's Observatory in London, making Iris the fourth asteroid ever found. A day on Iris lasts only 14 hours, and surface temperatures range from -148 degrees Celsius to -63 degrees Celsius, depending on solar exposure during the asteroid's 3.68-year orbit. The orbit brings Iris as close as 1.84 astronomical units to the Sun, making it one of the inner main belt asteroids with an orbital path that crosses Mars's orbit. Spectroscopic analysis reveals a composition of silicate rock mixed with metallic iron and nickel, similar to ordinary chondrite meteorites, with surface minerals including olivine and pyroxene. Scientists discovered that Iris is a member of the Iris family, though it has very few family members, suggesting either an old collision that has dispersed most fragments, or simply that Iris has experienced fewer major impacts than most asteroids its size. The high albedo and position in the inner belt make Iris occasionally visible with binoculars, a bright wandering point against the stars that ancient astronomers tracked without telescopes. To rest on one of the brightest worlds in the asteroid belt, where the surface reflects sunlight so efficiently that this rock outshines asteroids twice its size, where the stony composition and metallic content create terrain that would glitter under a harsh sun, where every footstep would kick up bright dust that settles back in slow motion under the minimal gravity. Your tent on asteroid Hebe, approximately 186 kilometers in diameter, would anchor to stony terrain that might be the source of the most common meteorites falling to Earth today. Imagine camping on this E-type asteroid where Carl Henck discovered it on July 1, 1847, from Dresden, Prussia, making it the sixth asteroid ever found and ending a 38-year gap since the discovery of Vesta. A day on Hebe lasts 7.27 hours, and the asteroid orbits the Sun every 3.78 years at an average distance of 2.43 astronomical units, following a moderately eccentric path through the inner main belt. Surface temperatures range from -153 degrees Celsius to -68 degrees Celsius, and spectroscopic observations reveal a composition matching H ordinary chondrite meteorites, the most common type found on Earth. Scientists analyzing Hebe's orbit and composition discovered it resides near a resonance that can efficiently deliver fragments to Earth-crossing orbits, making it the likely parent body of the H chondrites that account for about 40% of all meteorite falls. The asteroid's surface shows evidence of space weathering, where solar, wind, and micrometeorite impacts have darkened and reddened the outer layer over billions of years. Observations detected variations in Hebe's spectrum across its surface, suggesting either compositional differences or varying degrees of weathering in different regions. To close your eyes, knowing that pieces of this world have been falling to Earth for millions of years, that fragments of Hebe might rest in museums on every continent, that you could be sleeping on the parent body of meteorites that Egyptians witnessed falling from the sky 5,000 years ago, that ancient humans picked up without understanding they held pieces of a world orbiting between Mars and Jupiter. On asteroid Flora, approximately 128 kilometers in diameter, your habitat would sit on the largest member of the Flora family, one of the most populous asteroid groups with over 13,000 identified members. Picture your base, where John Hinn discovered this S-type asteroid on October 18, 1847, from London, naming it after the Roman goddess of flowers and spring. A day on Flora lasts only 12.87 hours, and the asteroid follows a 3.27-year orbit at an average distance of 220 astronomical units, making it an inner main belt object. Surface temperatures vary from -148 degrees Celsius to -53 degrees Celsius, and the asteroid's relatively high albedo of 24% makes it occasionally visible with binoculars during favorable oppositions. Scientists studying the Flora family discovered the catastrophic collision that created this family occurred approximately 1 billion years ago, shattering a larger parent body and creating the fragments we observe today, spread across a vast region of the inner belt. Spectroscopic analysis shows Flora has a stony composition rich in olivine and pyroxene, similar to L-ordinary chondrite meteorites, and some researchers suggest Flora family members might be the source of some meteorites reaching Earth. The asteroid's small size yet large family membership makes it an ideal laboratory for studying catastrophic disruption, where a single impact broke apart a 150-kilometer body and scattered the pieces across millions of kilometers. This reminds us that Flora is simultaneously a world and a crime scene, the largest surviving fragment of a violent event that occurred when Earth was in the middle of the Proterozoic Eon, when oxygen was accumulating in our atmosphere, when eukaryotic cells were beginning to experiment with multicellular structures, when one rock in space struck another and changed the asteroid belt's population forever. Your sleeping module on asteroid Metis, approximately 190 kilometers in diameter, would rest on stony terrain where Andrew Graham discovered this E-type asteroid on April 25, 1848, from Mercury Observatory in Ireland. Imagine camping on a surface that reflects about 24% of sunlight, where a day lasts only 5.08 hours, making Metis one of the faster rotating large asteroids in the belt. The asteroid orbits the Sun every 3.69 years at an average distance of 239 astronomical units, and surface temperatures range from -153 degrees Celsius in shadow to -68 degrees Celsius in direct sunlight. Spectroscopic observations classify Metis as an S-type asteroid with a composition of silicate rock and metallic iron, showing absorption features consistent with olivine and pyroxene minerals. Scientists analyzing light curves discovered that Metis has an irregular, somewhat elongated shape with dimensions approximately 190 by 170 by 150 kilometers, suggesting either incomplete gravitational rounding or significant mass loss from ancient impacts. The asteroid shows evidence of space weathering on its surface, where cosmic ray bombardment and micrometeorite impacts have altered the spectral signature of the outer regolith layer. Metis belongs to no identified asteroid family, suggesting it has survived as an intact body without experiencing the catastrophic collisions that created family groups, to rest on a world spinning so rapidly that your sense of day and night would cycle faster than a typical work meeting, where the sun would arc across the black sky and disappear in less than 3 hours, where you'd experience more than 4 sunrises during a single Earth day, where the rapid rotation creates a slight equatorial bulge measurable in the asteroid's shape. Sleeping on asteroid Hygeia's moon, if one were ever discovered, would offer a unique vantage point, but since Hygeia appears to be solitary, your tent on asteroid Astrea would instead rest on terrain approximately 119 kilometers wide, Picture camping, where Carl Henck discovered this asteroid on December 8, 1845. From Dryzen, ending a 38-year drought in asteroid discoveries and becoming the first asteroid found by an amateur astronomer. A day on Astrea lasts 16.81 hours, one of the longer rotation periods among asteroids, giving you an extended night under the stars. The S-type asteroid orbits the Sun every 4.13 years at an average distance of 2.58 astronomical units, with surface temperatures varying from -158 degrees Celsius to -73 degrees Celsius. Spectroscopic analysis reveals a stony composition similar to ordinary chondrite meteorites, with surface minerals including olivine, pyroxene, and metallic iron-nickel alloys. Scientists studying Astrea's slow rotation suggested it might be in a tumbling state, though more recent observations indicate a stable rotation axis. The asteroid's discovery reignited systematic searches for minor planets,